Hello, hello. Let me just notify everyone that I'm here. Huh. No. Alright. That's there. Yeah, that should be good. And I've got that all going, okay, I think I've got everything. Shaders! Huzzah! So, like I did last stream, I'm going to describe what I do at the beginning of the stream. So, this is Hargus Flirting Games, indie game studio. I am the lead developer. I am currently reading through all of the Godot document, or not all of the Godot documentation, but a lot of the Godot documentation to learn Godot, so that I can actually make the game in Godot. Yeah. I want to say that's everything. I hope that's everything. Look at this little guy. Just a little ducky. And he goes right up here. On top of you guys. You guys don't see him, but I do. I see him. He's very cute. I like him. Alright, introduction to shaders. This page explains what shaders are and will give you an overview of how they work in Godot. For detailed reference of the engine's shading language, see shading language. Shaders are a special kind of program that runs on graphics processing units, GPUs. They were initially used to shade 3D scenes, but can nowadays do much more. You can use them to control how the engine draws geometry and pixels on the screen, allowing you to achieve all sorts of effects. Modern rendering engines like Godot draw everything with shaders. Graphics cards can run thousands of instructions in parallel, leading to incredible rendering speed. Because of their parallel nature, though, shaders don't process information the way a typical program does. Shader code runs on each vertex or pixel in isolation. You cannot store data between frames either. As a result, when working with shaders, you need to code and think differently from other programming languages. Suppose you want to update all the pixels in a texture to a given color. In GDScript, your code would use for loops. Your code is already part of a loop in a shader, so the corresponding code would look like this: void fragment color sim color. Note: the graphics card calls the fragment function once or more for each pixel it has to draw. More on that below. Think. Like some allergy relief. Already kind of stuffy. And I just woke up like an hour ago, so I don't know what's up with that. Shaders in Godot. Godot provides a shading language based on the popular OpenGL shading language, GLSL, but simplified. The engine handles some of the lower level initialization work for you, making it easier to write complex shaders. In Godot, shaders are made up of main functions called processor functions. Processor functions are the entry point for your shader into the program. There are 7 different different processor functions. The vertex function runs over all the vertices in the mesh and sets their positions and some other per vertex variables used in canvas item shaders and spatial shaders. The fragment function runs for every pixel covered by the mesh. It uses value output by the vertex function interpolated between the vertices, used in canvas item shaders and spatial shaders. The light function runs for every pixel, and for every light it takes variables from the fragment function and from its previous runs used in canvas item shaders and spatial shaders. The start function runs for every particle in a particle system once when the particle is first spawned, used in particle shaders. The process functions run for every particle in a particle system for each frame, used in particle shaders. The sky function runs for every pixel in the radiance cube map when the radiance cube map needs to be updated, and for every pixel on the screen used in sky shaders. The fog function runs for every voxel. Voxel, huh? Never heard that term before. In the volumetric fog voxel buffer that intersects with the fog volume used by fog shaders. Warning! The light function won't run if the vertex lighting render mode is enabled, or if rendering quality shading force vertex shading is enabled in the project settings. It's enabled by default on mobile platforms. Note, Godot also exposes an API for users to write totally custom SL shaders. For more information, see using compute shaders. Render types. Instead of supplying a general purpose configuration for all uses, 2D, 3D, particle, sky, fog, you must specify the type of shader you're writing. Different types support different render modes, built-in variables, and processing functions. In Godot, all shaders need to specify their type in the first line like so, shader type spatial. Here are the available types. Spatial for 3D rendering, canvas item for 2D rendering, particles for particle systems, sky to render skies, fog to render fog volumes. Render modes. Shaders have optional render modes you can specify on the second line after the shader type, like so. Render modes alter the way Godot applies the shader. For example, the unshaded mode makes the engine skip the built-in light processor function. Each shader type has different render modes. See the reference for each shader type for a complete list of render modes. Vertex processor. The vertex processing function is called once every vertex and spatial and canvas item shaders. Each vertex in your world's geometry has properties like a position and color. The function modifies those values and passes them to a fragment function. You can also use it to send extra data to the fragment function using varyings. By default, Godot transforms your vertex information for you, which is necessary to project geometry onto the screen. You can use render modes to transform the data yourself. See the spatial shader doc for an example. Fragment processor. The fragment processing function is used to set up the Godot material parameters per pixel. This code runs on every visible pixel the object or primitive draws. It is only available in spatial and canvas item shaders. The standard use of the fragment function is to set up material properties used to calculate lighting. For example, you would set the values for roughness, rim, or transmission, which would tell the light function how the lights respond to that fragment. This makes it possible to control a complex shading pipeline without the user having to write much code. If you don't need this built-in functionality, you can ignore it and write your own light processing function, and Godot will optimize it away. For example, if you do not write a value to rim, Godot will not calculate rim lighting. During compilation, Godot checks to see if rim is used. If not, it cuts all the corresponding code out. Therefore, you will not waste calculations on the effects that you do not use. Light processor. The light processor runs per pixel too. It runs once for every light that affects the object. It does not run if no lights affect the object. It exists as a function called inside the fragment processor and typically operates on the material properties set up inside the fragment function. The light processor works differently in 2D than it does in 3D. For a description of how it works in each, see their documentation, canvas item shaders and spatial shaders respectively. Shading reference. Shading language. I need to turn that on. Forgot something. Specifically, I forgot to turn on the the light in here. Which... Really?
What? Really what?
You
Clean
turned
up,
off the
Naya.
light. What?
Clean up, Naya. Jeez.
It works.
Huh?
It works.
I'm talking about your garbage. Clean up, Naya.
The bowl that I reuse.
You use the same freaking bowl. I don't know how many times I rinsed out, making more noodles in it. Rinsed out,
Yeah.
I got my face full of.
Shading language. Introduction. Godot uses a shading language similar to GLSL ES 3.0. Most data types and functions are supported, and the few remaining ones will likely be added over time. If you are already familiar with GLSL, the Godot Shader Migration Guide is a resource that will help you transition from regular GLSL to Godot's shading language. I really want to skip this, because we're so close to the end here. So close. Because we got shaders, user interface, and then... And then we have this. We have all of this. Okay. Data types. Most GLSL ES 3.0 data types are supported. Void. Void data type useful for functions that return nothing. Boolean. Boolean data type can only contain true or false. B vector 2, 2-component vector of booleans. B vector 3, 3-component vector of booleans. B vector 4, 4-component vector of booleans. Int 32-bit signed scalar integer. IVEC2, 2-component vector of signed integers. IVEC3, 3-component vector of signed integers. IVEC4, 4-component vector of signed integers. UINT, unsigned scalar integer, can't contain negative numbers. UVEC2, 2-component vector of unsigned integers. UVEC3, 3-component vector of unsigned integers. UVEC4, 4-component vector of unsigned integers. Float, 32-bit float point scalar. VEC2, 3, and 4. Component float, vector of floating point values. MAT2, 3, 4. 2x2, 3x3, or 4x4 matrix in column major order. Sampler 2D. Sampler type for binding 2D textures, which are read as flow. iSampler 2D, sampler type for binding 2D textures, which are read as signed integer. uSampler 2D, sampler type for binding 2D textures, which are read as unsigned integer. Sampler 2D array, sampler type for binding 2D texture arrays, which are read as float. iSampler 2D array, sampler for type for binding 2D texture arrays, which are read as signed integer. uSampler 2D array, sampler type for binding 2D texture arrays, which are read as unsigned integer. Sampler 3D, sampler type for binding 3D textures, blah blah blah. Sampler cube, sampler type for binding cube maps, which are read as float. Sampler cube array, sampler type for binding cube map, this is... Sampler external OES, external sampler type only supported in compatibility or Android platform. These types can also be put inside arrays or structures, which are also usable as function parameters or return values. Arrays can be used as uniforms, but structures cannot. Warning: local variables are not initialized to a default value such as 0.0. If you use a variable without assigning it first, it will contain whatever value is already present at that memory location, and unpredictable visual glitches will appear. However, uniforms and varyings are initialized to a default value. Comments: the shading language supports the same common syntax used in C# and C++ using // for single line comments, and /*/ for multi-line comments. Additionally, you can use documentation comments that are displayed in the inspector when hovering a shader parameter. Documentation comments are currently only supported when placed immediately above a uniform declaration. These documentation comments only support the multi-line comment syntax, even if used on a single line. It must use 2 leading asterisks /** instead of just one /*. The asterisks on follow-up lines are not required but are recommended as per the shader style guide. These asterisks are automatically stripped by the inspector so they won't appear in the tooltip. Casting, just like GLSL ES 3.0, implicit casting between scalars and vectors of the same size but different type is not allowed. Casting of types of different size is not allowed. That was weird. Conversion must be done explicitly via constructors. Example: float A equals 2, invalid. Float A equals 2.0, valid. Float A equals float 2, valid. Okay. Default integer constants are signed, so casting is always needed to convert to unsigned. Int A equals 2, valid. Uint A equals 2, invalid. Uint A equals uint 2, valid. Members. Individual members of vector types are accessed via the X, Y, Z, and W members. Alternatively, using RGB and A also works and is equivalent, using whatever fits best for your needs. For matrices, use the M-column row indexing syntax to access each scalar, or M-column to access a vector by column index. For example, for accessing the Y component of the translation from a mat4 transform matrix, 4th column, 2nd line, you use M31 or M3.Y. Construction of vector types must always pass the required amount of scalars. Vector 4a equals vector 4 0.0, 1.0, 2.0, 3.0. Vector 4a equals vector complementary vectors and or scalars. Vector 4a, vector 4, vector 2, 0.0, 1.0, vector 2, 2.0, 3.0. Okay. Vector 4a equals vector 4, vector 3, 0.0, 1, 2, 3. A single scalar for the whole vector. Vector 4a, vector 4, 0. Construction of matrix types requires vectors of the same dimension as a matrix, interpreted as columns. You can also build a diagonal matrix using matrix float syntax. Accordingly, mat4 1.0 is an identity matrix. Matrices can also be built from a matrix of another dimension. There are 2 rules. If a larger matrix is constructed from a smaller matrix, the additional rows and columns are set to the values they would have if in an identity matrix. 1. If a smaller matrix is constructed from a larger matrix, the top left submatrix of the larger matrix is used. Why are there numbers there? Mat3 basis, mat3 modal matrix, mat4, m4 equals mat4 basis, mat2, m2, mat2, m4. Swizzling. It is possible to obtain any combination of components in any order as long as the result is another vector type or scalar. This is easier shown than explained. Vector 4a equals vector 4, 0, 1, 2, 3. Vector 3b, a, RGB. Creates a vector 3 with vector 4 components. Interesting. So it takes the RGB, but not the last one, I assume. Vector 3b equals a GGG, also valid, creates a vector 3 and fills it with a single vector 4 component. Okay. B will be vector 3, 2, 1, 0. XYZ also RGB, XYZW are equivalent. STP and STPQ for texture coordinates. Float C, B.W, invalid because W is not present in vector 3, B. Vector 3C, B, XRT, invalid, mixing different styles is forbidden. That checks out. That makes sense. B.RRR equals ARGB, invalid assignment with duplication. B.BGR equals A.RGB, valid assignment. B's blue component will be A's red and vice versa. Precision. It is possible to add precision modifiers to data types, use them for uniforms, variables, arguments, and varyings. Low poly, vector 4, A, vector 4, 0, 1, 2, 3. Low precision, usually 8 bits per component, per component mapped to 0 to 1. Medium vector 4, A, vector 4, 0, 1, 2, 3. Medium precision, usually 16 bits or half float. High vector 4, or high poly, vector 4, A, vector 4, 0, 1, 2, 3. High precision, low precision, medium precision, high precision. High precision uses full float or integer range, 32-bit default. Using lower precision for some operations can speed up the math involved at the cost of less precision. This is rarely needed in the vertex processor function, where full precision is needed most of the time, but is often useful in the fragment processor. Some architectures, mainly mobile, can benefit significantly from this, but there are downsides such as the additional overhead of conversion between precisions. Refer to the documentation of the target architecture for further information. In many cases, mobile drivers cause inconsistent or unexpected behavior, and it is best to avoid specifying precision unless necessary. Arrays. Arrays are containers for multiple variables of a similar type. Local arrays. Local arrays are declared in functions. They can use all the allowed data types, except samplers. The array declaration follows a C-style syntax. Constant plus precision plus type name plus identifier plus array size. Void fragment, float array 3. They can be initialized at the beginning like float array 3, float 3, 1.50, first constructor. Int array 3 equals int 210, second constructor. Vector 2 array 3, vector 2, 1.0, vector 2, 0.5, 0.5, vector 2, 0. Third constructor. Boolean array, true, true, false. Fourth constructor. Size is defined automatically from the element count. You can declare multiple arrays even with different sizes in one expression. Float A3, float 3, 1.50. B2, 1.5. C, 0.7. D, 0. E, 5. To access an array element, use the indexing syntax. Float array 3. Array 0 equals 1. Setter. Color R. Array 0. Getter. Okay, so it's grabbing... So it's grabbing R from ARR. Arrays also have a built-in function, .length, not to be confused with the built-in length function. It doesn't accept any parameters and will return the array size. Note, if you use an index either below 0 or greater than array size, the shader will crash and break rendering. To prevent this, use length, if, or clamp functions to ensure the index is between 0 and the array's length. Always carefully test and check your code. If you pass a constant expression or a number, the editor will check its bounds to prevent this crash. Float array equals 1 or 0, 1.5, negative 1. It's also have built-in length, not to be confused with length function. It doesn't accept any parameters and will return the array size. For int I equals 0, I is less than array length I plus plus. Okay, I assume that's a for loop. Yeah, that's just a for loop. Note, if you use an... Oh, I already read that. Global arrays. You can declare arrays in global space as either constant or uniform. Hello, Shelby. What's the Shelby doing? Oh, what's the Shelby doing? Global arrays. You can declare global arrays in global space as either constant or uniform. Shader type spatial, constant low poly vector 3, v1, ultra kill, low poly vector 3, 1, vector 3, 0, 0, 1. Uniform low poly vector 3, w1. Void fragment, albedo, v0 plus w0. Note, global arrays use the same syntax as local arrays, except with a constant or uniform added to their declaration. Note that uniform arrays can't have a default value. Constants. Use the constant keyword before a variable to a declaration to make that variable immutable, which means that it cannot be modified. All basic types, except samplers, can be declared as constants. Accessing and using a constant value is slightly faster than using a uniform. Constants must be initialized at their declaration. Constants cannot be modified and additionally cannot have hints, but multiple of them, if they have the same type, can be declared in a single expression. Similar to variables, arrays can also be declared with constant. Constants can be declared both globally outside of any function or locally inside a function. Global constants are useful when you want to have access to a value throughout your shader that does not need to be modified. Like uniforms, global constants are shared between all shader stages, but they are not accessible outside the shader. Constants of the float type must be initialized using period notation after the decimal part or by using this scientific notation. The optional f post suffix is also supported. Same using suffix for clarity. Gives 0.1 using the scientific notation. 1e negative 1. Scientific notation is amazing. Sorry, I'm just cleaning off my glasses. They were dirty. No, I don't want to bother with the glasses cleaner that I should use. Dusty. Constants of the float type must be initialized using constants of the UINT unassigned int type must have a U suffix to differentiate them from signed integers. Alternatively, this can be done using the UINT x built-in conversion function. UINT a equals 1 U, UINT b equals uint 1. Structs. Structs are compound types which can be used for better abstraction of shader code. You can declare them at the global scope like structure, point light, vector 3, position, vector 3, color, float, intensity. After declaration, you can instantiate and initialize them like void fragment, point light, light. There's just a space there? Weird. Light dot position equals vector 3, 0. Light color, vector 3, 1, 0, 0. Light intensity, 0.5. Or use structure construction for same purpose. Point light, point light, vector 3, 0. Vector 3, 1, 0, 0. 0.5. Structures may contain other structure or array. You can also instance them as global constant. Shader type, spatial. Structure scene, point light, lights 2, constant scene, point light 2, point light, vector 3, 0, 0, 0, vector 3, 1, 0, 0, 1. Point light, vector 3, 0, 0, 0, vector 3, 1, 0, 0, 1. Void fragment, albedo scene, light 0 color. You can also pass them to functions. Scene constructor scene, point light, light 1, point light, light 2, return scene, light 1, light 2. Void fragment, color RGB. Construct scene, point light, vector 3, 0, 0, 0, vector 3, 1, 0, 0, 1. Point light, vector 3, 0, 0, 0, vector 3, 1, 0, 1, 1. Lights 0 color. Operators. Godot shading language supports the same set of operators as GLSL as 3.0. Below is a list of them in preceding order. 1. Highest parenthetical grouping operator. 2. Unary plus minus exclamation mark tilde. 3. Multiplicative division multiplication remainder. 4. Additive addition subtraction. 5. Bitwise shift. 6. Relational. 7. Equality. 8. Bitwise and. 9. Bitwise exclusive or. 10. Bitwise inclusive or. 11. Logical and. 12. Lowest. Logical inclusive or. Note, most operators that accept vectors or matrices, multiplication, division, etc., operate component-wise, meaning the function is applied to the first value of each vector and then on the second value of each vector, etc. Some examples. Operation. Equivalent scalar operation. 4, 5, 6. 4 plus 2, 5 plus 2, 6 plus 2. Okay. Alright. Matrix 2, vector 2, 1, 2, vector 2, 3, 4, plus 10. Okay. The GLSL language specification says under section 5.10, vector and matrix operations. With a few exceptions, operations are component-wise. Usually when an operator operates on a vector or matrix, it is operating independently on each component of the vector or matrix in a component-wise fashion. The exceptions are matrix multiplied by vector, vector multiplied by matrix, and matrix multiplied by matrix. These do not operate component-wise, but rather perform the correct linear algebraic multiply. Flow control. Peach tea. Godot shading language supports the most common types of flow control. If, else, if, and else. If condition, else if, other condition, else. Ternary operator. This is an expression that behaves like if else and returns the value of condition, evaluates a true, result will be 9. Otherwise, result will be 5. And result equals condition, question mark, 9, 5. I have no idea what that means. Switch. I should be signed integer expression. Switch I, case -1, break. Case 0, return. Break or return to avoid running the next case. Case 1, fall through, no break or return, will run the next case. Case 2, break. Default, only run if no case above matches. Optional, break. For loop, best used when the number of elements to iterate on is known in advance. For int, I equals 0, I is less than 10, I plus plus. While loop, best used when the number of elements to iterate on is not known in advance. While condition. Do while like this, but always runs at least once, even if condition never relates to true. Do while condition. Keep in mind that in modern GPUs, an infinite loop can exist and can freeze your application, including editor. Godot can't protect you from this, so be careful not to make this mistake. Also, when comparing floating point values against a number, make sure to compare them against a range instead of an exact number. A comparison like if value equals 0.3 may not evaluate to true. Floating point math is often approximate and can defy expectations. It can also behave differently depending on the hardware. Don't do this. Float value 0.1 plus 0.2 may not evaluate to true if value equals 0.3. Instead, always perform a range comparison with an epsilon value. The larger the floating point number and the less precise the floating point number, the larger the epsilon value should be. See floating point guide for more information. Constant epsilon 0.0001 if value is less than or equal to 3 minus epsilon and value is greater if value is greater than or equal to 0.3 minus epsilon and value is less than or equal to 0.3 plus epsilon. See floating point guide for information. Discarding fragment light and custom functions called from fragment or light can use the discard keyword. If used, the fragment is discarded and nothing is written. Beware, the discard has performance cost when used, and it will prevent the depth pre-pass from being effective on any surfaces used in the shader. Also, a discard pixel still needs to be rendered in the vertex shader, which means a shader that uses discard on all of its pixels is still more expensive to render compared to not rendering any object in the first place. Functions. It is possible to define functions in a Godot shader. They use the following syntax. Ret type function name arguments. Return ret type if returning a value. A more specific example. Integer sum2, integer a, integer b. Return a plus b. You can only use functions that have been defined above higher in the editor. The function from which you are calling them, redefining a function that has already been defined above or is a built-in function name will cause an error. Function arguments can have special qualifiers. In means the argument is only for reading, default. Out means the argument is only for writing. In-out means the argument is fully passed via reference. Constant means the argument is a constant and cannot be changed. May be combined with in qualifier. Example below. Void sum2, integer a, integer b, in-out into result. Result equals a plus b. Function overloading is supported. You can define multiple functions with the same name, but different arguments. Note that implicit casting in overload functions function calls is not allowed, such as from integer to float, 1.0 to 1.0. Vector 3, get color, integer t, return vector 3, 1, 0, 0, red color. Vector 3, get color, float t, return vector 3, 0, 1, 0, green color. Void fragment, vector 3, red, get color 1. Vector 3, green, get color 1.0. Varyings. To send data from the vertex to the fragment or light processor function, varyings are used. They are set for every primitive vertex in the vertex processor, and the value is interpolated for every pixel in the fragment processor. Varying can also be an array. It's also possible to send data from fragment to light processors using varying keyword. To do so, you can assign it in the fragment and use it in the light function. Shark type spatial, varying vector 3, some light, void fragment, some light, albedo, times 100, make a shining light. Void light, diffuse light, some light. Note that varying may not be assigned in custom functions or light processor function like shader type spatial, varying float test, void foo, test equals 0, error. Void vertex, test equals 0. Void light, test equals 0, error 2. This limitation was introduced to prevent incorrect usage before initialization. Interpolation qualifiers. Certain values are interpolated during the shading pipeline. You can modify how the interpolators are done by using interpolation qualifiers. Shader type spatial. Varying flat vector 3, our color. Void vertex, our color RGB. Void fragment, albedo, our color. There are two possible interpolation qualifiers. Qualifier description. Flat, the value is not interpolated. Smooth, the value is interpolated in a prospective correct fashion. This is the default. Uniforms. Passing values to shaders is possible with uniforms, which are defined in the global scope of the shader outside of functions. When a shader is later assigned to a material, the uniforms will appear as editable parameters in the materials inspector. Uniforms can't be written from within the shader. Any data type except for void can be uniform. Shader type, spatial, uniform float, some value. Uniform vector 3, colors 3. You can set uniforms in the editor in the materials inspector. Alternatively, you can set them from code. Uniform hints. Godot provides optional uniform hints to make the compiler understand what the uniform is used for and how the editor should allow users to modify it. Shader type spatial. Uniform vector 3 color, source color, uniform float amount, hint range 0, 1. Uniform vector 4 other color, source color vector 4, 1. Default values go after the hint. Uniform sampler 2D image, source color. Uniforms can also be assigned default values. Uniform vector 4, sum color, vector 4 is 0. Uniform vector 4, sum color, source color, vector 4 1.0. Note that when adding a default value and a hint, the default value goes after the hint. Full list of uniform hints below. Source color, hint enum, string 1, string 2. Hint range, min, max, step, source color, hint normal, hint default white, hint default black, hint default transparent, hint anisotropy. Anisotropy? I have no idea. Interesting. Hint roughness RGBA, normal, gray. Filter nearest linear, mipmap, anisotropic. Repeat, enable, disable. Hint screen texture, hint depth texture, hint normal roughness texture. Using hint enum, you can access int values as a readable drop-down widget using the hint enum uniform. You can assign explicit values to the hint enum uniform using the colon syntax similar to GD script. The value will be stored as an integer corresponding to the index of the selected option, i.e. 0, 1, or 2, or the value assigned by colon syntax, i.e. 30, 60, or 200. When setting the value with setShader parameter, you must use the integer value, not the string name. Huh. Interesting. Using source color. Any texture which contains sRGB color data requires a source color hint in order to be correctly sampled. This is because Godot renders in linear color space, but some textures contain sRGB color data. If this hint is not used, the texture will appear washed out. Albedo and color textures should typically have a source color hint. Normal, roughness, metallic, and height textures typically do not need a source color hint. Using source color hint is required in the Forward Plus and mobile renders and in canvas item shaders. When HDR2D is enabled, the source color hint is optional for the compatibility renderer and for canvas item shaders if HDR2D is disabled. However, it is recommended to always use the source color hint because it works even if you change renderers or disabled HDR2D. Uniform groups. To group multiple uniforms in a section in the inspector, you can use group uniform keyword like this. You can close the group by using group uniforms, my group, uniform sampler test, group uniforms. The syntax also supports subgroups. It's not mandatory to declare the base group before this. Group uniforms, my group, my subgroup. Global uniforms. Sometimes you want to modify a parameter in many different shaders at once. With a regular uniform, this takes a lot of work as all of these shaders need to be tracked and the uniform needs to be set for each of them. Global uniforms allow you to create and update uniforms that will be available in all shaders, in every shader type, canvas items, spatial, particles, sky, and fog. Global uniforms are especially useful for environmental effects that affect many objects in a scene, like having foliage bend when the player is nearby, or having objects move with the wind. Note, global uniforms are not the same as global scope for an individual shader. While regular uniforms are defined outside of shader functions and are therefore a global scope of the shader, global uniforms are global to all shaders in the entire project, but within each shader, are also in the global scope. To create a global uniform, open the project settings, then go to the Shader Globals tab. Specify a name for the uniform, case sensitive, and a type, then click Add in the top right corner of the dialog. You can then edit the value assigned to the uniform by clicking the value in the list of uniforms. After creating a global uniform, you can use it in a shader as follows. Do I need this though? You know, I don't think so. I think getting shaders, convert GSL to Godot shaders, shader style guide, using a set viewport as texture, custom post processing, advanced post processing, making trees. I think I'm fine. Because I should be able to figure out, I'm fine not using shaders. I think. I don't want to learn them. So we're doing UI now. User interface. In this section of the tutorial, we explain the basics of creating a graphical user interface in Godot. Yay! You're getting so close. So close. UI building blocks. Like everything else in Godot, the user interface is built using nodes, specifically control nodes. There are many different types of controls which are useful for creating specific types of UIs. For simplicity, we can separate them into two groups, content and layout. Typical content controls include button, labels, line edits, and text edits. Typical layout controls include box containers, margin containers, scroll containers, tab containers, pop-ups. The following pages explain the basics of using such controls: size and anchors, using containers, custom GUI controls, keyboard or controller navigation and focus, control node gallery, GUI skinning and themes. Godot features an in-depth skinning theming system for control nodes. The pages in this section explain the benefits of that system and how to set it up in your projects. Introduction to GUI skinning, using the theme editor, theme type variations, using fonts. Control node tutorials. The following articles cover specific details of using particular control nodes. BB code enrich text label. Creating applications. Godot can also be used to create applications rather than games. Creating applications. I'm probably going to skip over the creating application section, because I'm going to be making a game, not an application, so... Size and anchors. If a game was always going to be run on the same device and at the same resolution, positioning controls would be a simple matter of setting the position and size of each one of them. Unfortunately, that is rarely the case. While some configurations may be more common than others, devices like phones, tablets, and portable gaming consoles can vary greatly. Therefore, we often have to account for different aspect ratios. There are different ways to account for this, but for now, let's just imagine that the screen resolution has changed and the controls need to be repositioned. Some will need to follow the bottom of the screen, others the top of the screen, or maybe the right or left margins. This is done by editing the anchor offsets of controls, which behave similar to a margin. To access these settings, you will first need to select the custom anchor preset. Each control has 4 anchor offsets, left, right, bottom, and top, which correspond to the respective edges of the controls. By default, all of them represent a distance in pixels relative to the top left corner of the parent control, or in case there is no parent control, the viewport. So make the control wider, and wider you can make the right offset larger or make the left offset smaller. This lets you set the exact placement and shape of the control. The anchor properties adjust where the offsets are relative to. Each offset has an individual anchor that can be adjusted from the beginning to the end of the parent. So the vertical top, bottom anchor adjust from 0 top parent to 1 bottom of parent, with 0.5 being the center, and the control offsets will be placed relative to that point. The horizontal left-right anchors similarly adjust from left to right of the parent. Note that when you wish the... Hello, Bella. What are you doing? What are you doing? Sets will be placed relative to that point, horizontal left. That when you wish. Note that when you wish to wish the edge of the control to be above or left of the anchor point, you must change the offset value to be negative. For example, when horizontal anchors are changed to 1, the offset values become relative to the top right corner of the parent control or viewport. Adjusting two horizontal or two vertical anchors to different values will make the control change size when the parent control does. Here the control is set to anchor its bottom right corner to the parent's bottom right, while the top left control offsets are still anchored to the top left of the parent. So when resizing the parent, the control will always cover it, leaving a 20 pixel offset. Centering a control. To center a control to its parent, it set its anchors to 0.5 and each offset to half of its relative dimension. For example, the code below shows how a texture rectangle can be centered in its parent. Damn. Setting each anchor to 0.5 moves the reference point for the offsets to the center of its parent. From there, we can set negative offsets so that the control gets its natural size. Anchor presets. Instead of manually adjusting the offset and anchor values, you can use the toolbar's anchor menu above the viewport. Besides centering it, gives you many options to align and resize control nodes. Using containers. Anchors are an efficient way to handle different aspect ratios for basic multiple resolution handling into UIs. For more complex user interfaces, they can become difficult to use. This is often the case of games such as RPGs, online chats, tycoons, or simulations. Another common case where more advanced layout features may be required is in-game tools or simply just tools. All these situations require a more capable OS like user interface with advanced layout and formatting. For that, containers are more useful. Container layout. Containers provide a huge amount of layout power. As an example, the Godot editor user interface is entirely done using them. Bella, stop that. When a container-derived node is used, all children control nodes give up their own positioning ability. This means that the container will control their positioning, and any attempt to manually alter these nodes will be either ignored or invalidated the next time their parent is resized. Likewise, when a container-derived node is resized, all its children will be repositioned according to it, with the behavior based on the type of container used. Example of HBox container resizing children buttons. The real strength of containers is that they can be nested as nodes, allowing the creation of very complex layouts that resize effortlessly. Sizing options. When adding a node to a container, the way the container treats each child depends mainly on their container sizing options. These options can be found by inspecting the layout of any control that is a child of a container. Sizing options are independent for vertical and horizontal sizing, and not all containers make use of them, but most do. Fill ensures the control fills the designated area within the container, no matter if a control expands or not. See below. It will only fill the designated area when this is toggled on. It is by default. Expand attempts to use as much space as possible in the parent container in each axis. Controls that don't expand will be pushed away by those that do. Between expanding controls, the amount of space they take from each other is determined by the stretch ratio. See below. This option is only available when the parent container is of the right type. For example, the HBox container has this option for horizontal sizing. Shrink begin when expanding. Try to remain at the top left of the expanding area. Shrink center when expanding. Try to remain at the center of the expanding area. Shrink end when expanding. Try to remain at the right or bottom of the expanding area. Stretch ratio, the ratio of how much expanding controls take up the available space in relation to each other. A control with 2 will take up twice as much available space as one with 1. Experimenting with these flags and different containers is recommended to get a better grasp on how they work. Container types. Godot provides several container types out of the box as they serve different purposes. Box containers. Arranges child controls vertically or horizontally via HBox container and VBox container in the opposite of the designated directions, as in vertical for a horizontal container. It just expands the children. These containers make use of the stretch ratio property for children with the expand flag set. Grid container arranges child controls in a grid layout via grid container. Amount of columns must be specified. Uses both the vertical and horizontal expand flags. Margin container. Child controls are expanded toward the bounds of this control via margin container. Padding will be added on the margins depending on the theme configuration. Again, keep in mind that the margins are a theme value, so they need to be edited from the constants overrides section of each control. Tab container allows you to place several child controls stacked on top of each other via tab container, with only the current one visible. Changing the current one is done via tabs located in the top of the container via clicking. The titles are generated from the node names by default, although they can be overridden via tab container API. Settings such as tab placement and style box can be modified in the tab container theme overrides. Split container accepts only 1 or 2 children nodes, then places them side to side with a divisor via hsplit container and vsplit container. Respects both horizontal and vertical flags as well as ratio. The divisor can be dragged around to change the size relation between both children. Alright. That's useful. Panel container. A container that draws a style box, then expands children to cover its whole area via a panel container. Respecting the style box margins, it respects both the horizontal and vertical sizing options. This container is useful as a top-level control or just to add custom backgrounds to sections of a layout. Foldable container, a container that can be expanded or collapsed via foldable container. Child controls are hidden when it is collapsed. Scroll container accepts a single child node. If the child node is bigger than the container, scroll bars will be added to allow panning the node around via scroll container. Both vertical and horizontal size options are respected, and the behavior can be turned on or off per axis in the properties. Mouse wheel and touch drag, when touch is available, are also valid ways to pan the child's control around. As in the example above, one of the most common ways to use this container is together with a VBox container as child. Aspect ratio container. A container type that arranges its child controls in a way that preserves their proportions automatically when the container is resized via aspect ratio container. It has multiple stretch modes, providing options for adjusting the child's controls sizes concerning the container. Fill, width, control height, control width, and cover. It is useful when you have a container that needs to be dynamic and responsive to different screen sizes, if you want the child element to scale proportionally without losing their intended shapes. Flow container. Flow container is a container that arranges its children controls either horizontally or vertically via hflow container and via flow container. and via vFlow container. When the available space runs out, it wraps the children to the next line or column, similar to how text wraps in a book. It is useful for creating flexible layouts where the child controls just adjust automatically to the available space without overlapping. Center container. Center container is a container that automatically keeps all of its children controls centered within it at their minimum size. It ensures that the children controls are always aligned to the center, making it easier to create centered layouts without manually positioning via a center container. Sub-viewport container. This is a special control that will accept a single viewport node as a child, and it will display as if it was an image via a sub-viewport container. Creating custom containers. It is possible to create a custom container using a script. Here's an example of a container that fits children to its size. Custom GUI controls. Work in progress. Alright. Been an hour. I'm gonna use the bathroom. Fucking stub my toe on the tower of my PC. Salute bliss. Oh, what a shock. Watch where you walk. I'm the coast I run the place. King, that is my name. Those just feeling used. Oh, goddamn shame. Congratulations, all of my friends. Public relations of getting a friends. Put on your Sunday best because I'm nowhere close to quitting. So play the games and just ignore the plans, cause all that remains is how you prime your brains. Run to me and you're too blind to see that I'm the one who's running the show. Yeah. Alright, I'm back. Custom GUI controls. So many controls. Yet there are never enough. Creating your own custom controls that act just the way you want them to is an obsession of almost every GUI programmer. Nah. Keyboard controller navigation focus. It is a common requirement for a user interface to have full keyboard and controller support for navigation and interaction. There are two main reasons why this is beneficial for projects. Improved accessibility. Not everyone can use mouse or touch controls for interactions. Getting your project ready for consoles or just people who prefer to game with a controller on PC. Navigation between UI elements with keyboard or controller is done by changing which node is actively selected. This is also called changing UI focus. Every control node in Godot is capable of having focus by default. Some control nodes have the ability to automatically grab focus, reacting to built-in UI actions such as UI up, UI down, UI focus next, etc. These actions can be seen in the project settings in the input map and can be modified. Warning: Because these actions are used for focus, they should not be used for any gameplay code. Node settings. In addition to built-in logic, you can define what is known as focus neighbors for each individual control node. This allows you to finely tune the path the UI focus takes across the user interface of your project. The settings for individual nodes can be found in the inspector doc under the focus category of the control section. Neighbor options are used to define nodes for directional navigation, such as using arrow keys or D-pad on a controller. For example, the bottom neighbor will be used when navigating down with the down arrow or by pushing down with the D-pad. The next and previous options are used with the focus shift button, such as tab on desktop operating systems. Note: a node can lose focus if it becomes hidden. The mode setting, Bella, where's that Shelby? It's Bella. The mode setting defines how a node can be focused. All means a node can be focused by clicking on it with the mouse or selecting it with the keyboard or controller. Click means it can only be focused on by clicking on it. Finally, none means it can't be focused at all. Different control nodes have different default settings for this based on how they are typically used. For example, labeled nodes are set to none by default, while buttons are set to all. Make sure to properly configure your scenes for focus and navigation. If a node has no focus neighbor configured, the engine will try to guess the next control automatically. This may result in unintended behavior, especially in a complex user interface that doesn't have well-defined vertical or horizontal navigation flow. Necessary code. For keyboard and controller navigation to work correctly, any node must be focused by using code when the scene starts. Without doing this, pressing buttons or keys won't do anything. You can use the control grab focus method to focus a control. Here's a basic example of setting initial focus with code. Now when the scene starts, the start button node will be focused, and the keyboard or controller can be used to navigate between it and other UI elements. Okay. This is a short one. Control node gallery. Here's a list of common control nodes with their name next to them. The control gallery demo picture above can be found on GitHub. Introduction to GUI skinning. It is essential for a game to provide clear, informative, and yet visually pleasing user interface to its players. All control nodes come with a decently functional look out of the box. There is always room for uniqueness and case-specific tuning. For this purpose, Godot Engine includes a system for GUI skinning, or theming, which allows you to customize the look of every control in your user interface, including your custom controls. Here's an example of the system in action, a game with the GUI that is radically different from the default UI theme of the engine. A gear-up screen in Tank Kings, courtesy of Winter Pixel Games. Beyond achieving a unique look for your game, the system also enables developers to provide customization options to the end users, including accessibility settings. UI themes are applied in a cascading manner, i.e. they propagate from parent controls to their children, which means that font settings or adjustments for colorblind users can be applied in a single place and affect the entire UI tree. Of course, this system can also be used for gameplay purposes. Your hero-based game can change its style for the selected player character, or you can give different flavors to the sides in your team-based project. Basics of themes. The skinning system is driven by the theme resource. Every Godot project has an inherent default theme that contains the settings used by the built-in control nodes. This is what gives the controls their distinct look out of the box. A theme only describes the configuration. However, and it is still the job of each individual control to use that configuration in the way it requires to display itself. This is important to remember when implementing your own custom controls. Note, when the Godot editor itself relies on the default theme, but it doesn't look the same as a Godot project because it applies its own heavily customized theme on top of the default one. In principle, this works exactly like it would in your game as explained below. Theme items. The configuration that is stored in a theme consists of theme items. Each item has a unique name and must be one of the following data types. Color, a color value which is often used for fonts and backgrounds. Colors can also be used for modulation in controls and icons. Constant, an integer value, which can be used either for numeric properties of controls, such as the item separation in a box container, or for Boolean flags, such as the drawing of relationship lines in a tree. Font, a font resource which is used by controls that display text. Fonts contain most text rendering settings, except for its size and color. On top of that, alignment and text direction are controlled by individual controls. Font size, an integer value which is used alongside a font to determine the size at which the text should be displayed. Icon, a structural resource which is normally used to display an icon on a button, for example. Stylebox, a stylebox resource, a collection of configured options which define the way a UI panel should be displayed. This is not limited to the panel control, as styleboxes are used by many controls for their backgrounds and overlays. Different controls will apply style boxes in a different manner. Most notably, focus style boxes are drawn as an overlay to other style boxes, such as normal or pressed, to allow the base style box to remain visible. This means the focus style box should be designed as an outline or translucent box so that its background can remain visible. Theme types. To help with the organization of its items, each theme is separated into types, and each item must belong to a single type. In other words, each theme item is defined by its name. Its data type and its theme type is this combination must be unique within the theme. For example, there cannot be two color items named font color in a type called label, but there can be another font color item in a type line edit. The default Godot theme comes with multiple theme types already defined, one for every built-in control node that uses UI skinning. The example above contains actual theme items present in the default theme. You can refer to the theme properties section in the class reference for each control to see which items are available to it and its child classes. Note, child classes can use theme items defined for their parent class, button, and its derivatives being a good example of that. In fact, every control can use every theme item of any theme type, if it needs to, but for the clarity and predictability, we try to avoid that in the engine. It is important to remember that for child classes, that process is automated. Whenever a built-in control requests a theme item from the theme, it can omit the theme type, and its class name will be used instead. On top of that, the class names of its parent classes will also be used in turn. This allows changes in the parent class, such as button, to affect all derived classes without the need to customize every one of them. You can also define your own theme types, and additionally customize both built-in controls and your own controls. Because built-in controls have no knowledge of your custom theme types, you must utilize scripts to access those items. All control nodes have several methods that allow you to fetch theme items from the theme that is applied to them. Those methods accept the theme type as one of the arguments. To give more customizable opportunities, types can also be linked together as type variations. This is another use case for custom theme types. For example, a theme can contain a type header, which can be marked as a variation of the base label type. An individual label control can then be set to use the header variation for its type, and every time a theme item is requested from a theme, this variation will be used before any other type. This allows to store various presets of theme items for the same class of the control node in the single theme resource. Warning, only variations available from the default theme or defined in the custom project theme are shown in the inspector doc as options. You can still input manually the name of a variation that is defined outside of those two places, but it is recommended to keep all variations to the project theme. You can learn about creating and using theme variations in a dedicated article. Customizing a control. Each control node can be customized directly without the use of themes. This is called local overrides. Every theme property from the control's class reference can be overridden directly on the control itself, using either the inspector doc or scripts. This allows to make granular changes to a particular part of the UI while not affecting anything else in the project, including this control's children. Local overrides are less useful for the visual flair of your user interface, especially if you aim for consistency. However, for layout nodes, these are essential. Nodes such as box container and grid container use theme constants for defining separation between their children, and margin container stores its customizable margins in its theme items. Whenever a control has a local theme item override, this is the value that it uses. Values provided by the theme are ignored. Customizing a project. Out of the box, each project adopts the default project theme provided by Godot. The default theme itself is constant and cannot be changed, but its items can be overridden with a custom theme. Custom themes can be applied in two ways, as a project setting and as a node property throughout the tree of control nodes. There are two project settings that can be adjusted to affect your entire project. GUI theme custom allows you to set a custom project-wide theme, and GUI theme custom font does the same to the default fallback font. When a theme is requested by a control node, the custom project theme is present. If present, is checked first. Only if it doesn't have the default theme is checked. God. Yawning. Oh, shit. Oh, bye, Bella. Doggo. Where was I? Every control node also has a theme property, which allows you to set a custom theme for the branch nodes, starting with that control. This means that the control and all of its children and their children in turn would first check that custom theme resource before falling back on the project and the default themes. No, instead of changing the project setting, you can set the custom theme resource to the root. Most control node of your entire UI branch to almost the same effect. While in the running project, it will behave as expected. Individual scenes will still display using the default theme when previewing or running them directly. To fix that, you can set the same theme resource to the root control of each individual scene. For example, you can have a certain style for buttons in your project theme, but want a different look for buttons inside of a pop-up dialog. You can set a custom theme resource to the root control of your pop-up and define a different style for buttons within that resource, as long as the chain of control nodes between the root and the pop-up and the buttons is uninterrupted. Those buttons will use the styles defined in the theme resource that is closest to them. All other controls will be styled using the project-wide theme and the default theme styles. To sum it up, for an arbitrary control, its theme item lookup would look something like this. Check for local overrides of the same class, data type and name, using controls type variation, class name, and parent class names. Check every control starting from itself and see if it has a theme property set. If it does, check that theme for the matching item of the same name, data, and theme type. If there is no custom theme or it doesn't have the item, move the parent control. Repeat steps A through C until the root of the tree is reached or a non-control node is reached. Using controls type variation, class and name, and parent class names, check the project-wide theme if it's present. Using controls type variation, class name and parent class names, check the default theme. Even if the item doesn't exist in any theme, a corresponding default value for that data type will be returned. Bella Bella. Beyond controls, naturally, themes are an ideal type of resource for storing configuration for something visual. While the support for theming is built into control nodes, other nodes can use them as well, just like any other resource. An example of using themes for something beyond controls can be a modulation of sprites for the same units on different teams in a strategy game. A theme resource by defining a collection of colors and sprites with the help from scripts can use those colors to draw the texture. The main benefit being that you could make different themes using the same theme items for red, blue, and green teams, and swap them with a single resource change. Next! Using the theme editor. This article explains how to create and manage UI themes using Godot Editor and its theme editor tool. We recommend getting familiar with the basics behind GUI skinning/theming by reading Introduction to GUI Skinning. Before starting, the theme editor is a bottom panel tool that activates automatically when a theme resource is selected for editing. It contains the necessary UI for adding, removing, and adjusting theme types and theme items. It features a preview section for testing your changes live, as well as a window dialog for doing bulk operations of the theme items. Creating a theme. Like any other resources. What? Okay. Themes can be created directly in the file system dock by right-clicking and selecting New Resource, and selecting Theme and clicking Create. This is especially useful for creating project-wide themes. Themes can also be created from any control node. Selecting a control node in the scene hierarchy, then in the inspector, go to the theme property. From there you can select New Theme. This will create an empty theme and open up the theme editor. Keep in mind that resources created this way are bundled with the scene by default. Use the context menu to save the new theme to a file instead. While the theme editor provides the tools to manage theme types and items, themes also include the default fallback font that you can edit only using the inspector dock. Same applies to the contents of complex resource types, such as style boxes and icons. They open for editing in the inspector. Theme Editor Overview. The theme editor has two main parts. The main theme editor, located at the bottom of the Godot editor, aims to provide users with tools to quickly create, edit, and delete theme items and types. It gives visual tools for picking and changing controls, abstraction? The Amazing Digital Circus? Whoa! For abstracting the underlying theme concepts. The Manage Theme Item dialog, on the other hand, tries to address the needs of those who want to change themes manually. It's also useful for creating a new editor theme. Theme Previews. The left-hand side of the main editor has a set of preview tabs. The default preview tab is visible out of the box and contains most of the frequently used controls in various states. Previews are interactive, so intermediate states, example hover, can be previewed as well. Additional tabs can be created from arbitrary scenes in your project. The scene must have a control node as its root function as a preview. To add a new tab, click the Add Preview button and select the saved scene from your file system. If you make changes to the scene, they will not be reflected in your preview automatically. To update the preview, click the Reload button on the toolbar. Previews can also be used to quickly select the theme type to edit. Select the Picker tool from the toolbar and hover over the preview area to highlight control nodes. Highlighted control nodes display their class name or type variation if available. Clicking on the highlighted control opens it for editing on the right-hand side. Theme types and items. The right-hand side of the theme editor provides a list of theme types available in the editing theme resource, and the contents of the selected type. The list of types items is divided into several tabs, corresponding to each data type available in the theme color, colors, constants, styles, etc. If the Show Default option is enabled, then for each built-in type, its default theme values are displayed. Grayed out are displayed. Grayed out. If the option is disabled, only the items available in the editing theme itself are displayed. Individual items from the default theme can be added to the current theme by clicking on the Override button next to the item. You can also override all of the default items of the selected theme type by clicking on the Override All button. Overridden properties can then be removed with the Remove Item button. Properties can also be renamed using the Rename Item button, and completely custom properties can be added to the list by using the text field below it. Overridden theme items can be edited directly in the right-hand panel unless they are resources. Resources have rudimentary controls available for them, but must be edited in the inspector dock instead. Style boxes have a unique feature available where you can pin an individual style box from the list. Pinned style boxes acts like the leader of the pack, and all style boxes of the same type are updated alongside it. When you change its properties, this allows you to edit properties of several style boxes at the same time. While theme types can be picked from a preview, they can also be added manually. Clicking the plus button next to the type list opens the Add Item Type menu. In that menu, you can either select a type from the list, or you can enter an arbitrary name to create a custom type. Text field also filters the list of control nodes. Manage and import items. Click Manage Item. Click the Manage Items button. Clicking the Manage Items button brings up the Manage Theme Items dialog. In the Edit Items tab, you can view and add theme types, as well as view and edit the theme items of the selected type. You can create, rename, and remove individual theme items here by clicking the corresponding Add X item and specifying their name. You can also mass delete theme items either by their data type, using the brush icon in the list, or by their quality. Remove class items will remove all built-in theme items you have customized for control node type. Remove custom items will remove all the custom theme items for the selected type. Finally, remove all items will remove everything from the type. From the Import Items tab, you can import theme items from other themes. You can import items from the default Godot theme, the Godot editor theme, or another custom theme. You can import individual or multiple items. You can decide whether to copy or omit their data as well. There are several ways you can select and deselect the items, including by hand, by hierarchy, by data type, and everything. Opting to include the data will copy all theme items as they are to your theme. Omitting the data will create the items of the corresponding data type and name, but will leave them empty, creating a template of a theme in a way. Alright, I'll be right back. I have a thing to do real quick. Should take like only a couple minutes. Okay, I was checking my laundry. Should be done here soon. Then I'll have to go and change it out. Theme type variations. When designing a user interface, there may be times when a control node needs to have a different look than what is normally defined by a theme. Every control node has theme property overrides which allow you to redefine the styling for each individual UI element. This approach quickly becomes hard to manage if you need to share the same custom look between several controls. Imagine that you use gray, blue, and red variants of buttons throughout your project. Setting it up every time you add a new button element to your interface is a tedious task. To help with the organization and better utilize the power of themes, you can use theme type variations. These work like normal theme types, but instead of being self-sufficient and standalone, they extend another base type. Following the previous example, your theme can have different styles, colors, and fonts defined for the button type, customizing the looks of every button element in your UI. To then have a gray, red, or blue button, you would create a new type, example gray button, and mark it as a variation of the base button type. Type variations can replace some aspects of the base type, but keep others. They can also define properties that the base style hasn't defined. For example, your gray button can override the normal style from the base button and add font color that button has never defined. The control will use a combination of both types, giving priority to the type variation. Note, the way controls resolve what theme items they use from each type and each theme is better described in the Customizing a Project section of the Introduction to UI Skinning article. Creating a type variation. To create a type variation, open the theme editor, then click the plus icon next to the type dropdown on the right side of the editor. Type in what you want to name your theme type variation in the text box, then click Add Type. Below the type dropdown are the property tabs. Switch to the tab with a wrench and screwdriver icon. Click on the plus icon next to the base field. You can select the base type there, which would typically be the name of a control node class, example button label, etc. Type variations can also chain and extend other type variations. This works in the same way control nodes inherit styling of their base class. For example, check button inherits styles from button because corresponding node types extend each other. After you select the base type, you should now be able to see its properties on the other tabs in the theme editor. You can edit them as usual. Using a type variation. Now that a type variation has been created, you can apply it to your nodes in the inspector dock. Under the theme property of a control node, you can find the theme type variation property. It is empty by default, which means that only the base type has an effect on this node. You can either select a type variation from a drop-down list or input its name manually. Variations appear on the list only in the type variation belongs to the project-wide theme, which you can configure in the project settings. For any other case, you have to input the name of the variation manually. Click on the pencil icon to the right, then type in the name of the type variation and click to check mark icon to press enter. If a type variation with that name exists, it will now be used by the code. Using fonts. Godot allows you to set specific fonts for different UI nodes. Oh god, this one's long. Why is it so long? There are three different places where you can set up font usage. The first is the theme editor. Choose the node you want to set the font for and select the font tab. The second is in the inspector for control nodes under theme overrides fonts. Lastly, in the inspector settings for themes under default font, if no font override is specified anywhere, open sans semi-bold is used as the default project font. Note, since Godot 4.0, font sizes are no longer defined in the font itself, but are instead defined in the node that uses the font. This is done in the theme overrides font sizes section of the inspector. This allows changing the font size without having to duplicate the font resource for every different font size. There are two kinds of font styles: dynamic, TTF, OTF, WOFF, WOFF2 formats, and bitmap, BMF font, FNT font format, or monospaced image. Dynamic fonts are the most commonly used option, as they can be resized and still look crisp at higher sizes. Thanks to their vector-based nature, they can also contain a lot more glyphs while keeping a reasonable file size compared to bitmap fonts. Dynamic fonts also support some advanced features that bitmap fonts cannot support, such as ligatures, several characters transforming into a single different design. Tip: you can find freely licensed font files on websites such as Google Fonts and Font Library. Fonts are covered by copyright. Double check the license of a font before using it, as not all fonts allow commercial use without purchasing a license. See, also, you can see how fonts work in action using the Bitty and Font Features demo project. Dynamic fonts. True type font or collection, .ttf.ttc, open type font or collection, OTF, OTC, web open format 1, WOFF, web open font format 2, WOFF2. While WOFF and especially WOFF2 tend to result in smaller file sizes, there's no universally better font format. In most situations, it's recommended to use the font format that was shipped on the font developer's website. Bitmap fonts. Godot supports the BM font, FNT bitmap font format. This is a format created by the BMF font program. Many BM font compatible programs also exist, like BM Glyph or web-based font cutter. Alternatively, you can import any image to be used as a bitmap font. To do so, select the image in the file system dock, go to the import dock, change its import type to font data image font, then click re-import. Give me a second. The font's character set layout can be in any order, but orders that match standard Unicode are recommended as they require far less configuration to import. For example, the bitmap font below contains ASCII characters and follows standard ASCII ordering. Credit Liberquake scaled and cropped to exclude extended range. The following import options can be used to import the above font image successfully. Here's what they did for Q. Okay. Yeah, that works. The character ranges options is an array that maps each position on the image in tile coordinates, not pixels. The font atlas is traversed from left to right and top to bottom. Characters can be specified with decimal numbers 127, hexadecimal numbers 0x007f, or between single quotes. Quote tilde quote. Ranges can be specified with a hyphen between characters. For instance, 0-127 or 0x0000-0x007f denotes the full ASCII range. As another example, is equivalent to 32 to 127 and denotes the range of printable visible ASCII characters. Make sure the character ranges option doesn't exceed the number of columns or rows defined, otherwise the font will fail to import. If your font image contains margins not used for font glyphs, such as attribute information, try adjusting image margin. This is a margin applied only once around the whole image. If your font image contains guides in the form of lines between glyphs, or if spacing between characters appears incorrect, try adjusting character margin. The margin is applied for every imported glyph. If you need finer control over character spacing than what the character margin options provide, you have more options. For one, character ranges supports 3 additional arguments after the specified range of characters. These additional arguments control their positioning and spacing. They represent space advance x-axis offset and y-axis offset in that order. They will change the space advance and offset of each character by the amount of pixels written. Space advance is most useful. For example, your lowercase letters are thinner than your uppercase letters. Do note that the offsets can cause your text to be cropped off the edge of your label boundaries. Secondly, you can also set up kerning pairs for individual characters, specifying your kerning pair by typing two sets of characters separated by a space, then followed by another space, a number to specify how many extra or less pixels to space those two sets of characters when placed next to each other. If needed, your kerning pair characters can be specified by Unicode character code by entering /u xxxx. Loading a font file. To load a font file, dynamic or bitmap, use the resource dropdown quick load or load option next to a font property. Then navigate to the font file in question. You can also drag and drop a font file from the file system doc to the inspector property that accepts a font resource. Warning, in Godot 4.0 and later, texture filter and repeat properties are defined in the location where the texture is used rather than on the texture itself. This also applies to fonts, both dynamic fonts and bitmap fonts. Fonts that have a pixel art appearance should have bilinear filtering disabled by changing the rendering textures canvas textures default texture filter project setting to nearest. The font size must also be integer multiple of the design size, which varies on a per font basis. And the control node using the font must be scaled by an integer multiple as well, otherwise the font may look blurry. Font sizes in Godot are specified in pixels, not points. Keep in mind when comparing font sizes across different software. The texture filter mode can also be set on individual nodes that inherit from canvas item by setting canvas item.textureFilter. Font outlines and shadows. Font outlines and shadows can be used to improve readability when the background color isn't known in advance. For instance, this is the case for HUD elements that are drawn over a 2D or 3D scene. Font outlines are available in most nodes that derive from control in addition to label 3D. To enable outline for a font on a given node, configure the theme overrides font outline color and outline size in the inspector. The result should look like this. Hello world. Font outline example. Note, if using a font with MSDF rendering, its MSDF pixel range import option be set to at least twice the value of the outline size for outline rendering to look correct. Otherwise, the outline may appear to be cut off earlier than intended. Support for font shadows is more limited. They are only available in label and rich text label Additionally, font shadows always have a hard edge, but you can reduce their opacity to make them look more subtle. To enable font shadows on a given node, configure the font shadow color, shadow offset X, and shadow offset Y theme overrides in a label or rich text label node accordingly. The result should look like this. Font shadow example. Tip: you can create local overrides to font display in label nodes by creating a label settings resource that you reuse across label nodes. This resource takes priority over theme properties. Advanced font features. Oh, this is the longest section. By far. Anti-aliasing. You can adjust how the font should be smoothed out when rendering by adjusting anti-aliasing by hinting. These are different properties with different use cases. Anti-aliasing controls how glyph edges should be smoothed out when rastering the font. The default anti-aliasing method, grayscale, works well on every display technology. However, at small sizes, grayscale anti-aliasing may result in fonts looking blurry. The anti-aliasing sharpness can be improved by using LCD subpixel optimization, which exploits the subpixel patterns of most LCD displays by offsetting the font anti-aliasing on a per channel basis, red, green, blue. The downside is that it can introduce fringing on edges, especially on display technologies that don't use standard RGB subpixels, such as OLED displays. In most games, it's recommended to stick to the default grayscale anti-aliasing for non-game applications. LCD subpixel optimization is worth exploring. From top to bottom, disabled. You can definitely see that it's disabled. Grayscale. LCD subpixel, RGB. Looking at it closely, I can like just barely see the color outlines on it. Like just so barely. I have to look super closely at it to be able to even see the subpixel RGB shit. Oh, wait. And if I didn't know that it was using that, I would not have been able to see it. No, anti-aliasing cannot be changed on MSDF rendered fonts. These are always rendered with grayscale anti-aliasing. Hinting. Hinting controls how aggressively glyph edges should be snapped to pixels when rastering the font. None results in the smoothest appearance, which can make the font look blurry at small sizes. Light, default, is sharper by snapping glyph edges to pixels on the y-axis only, while full is even sharper by snapping glyph edges to pixels on both x and y axes. Depending on personal preference, you may prefer using one hinting mode over the other. Note, if changing the hinting mode has no visible effect after clicking re-import, it's usually because the font doesn't include hinting instructions. This can be resolved by looking for a version of the font file that includes hinting instructions, or enabling Force Auto Hinter in the import doc. This will use FreeType's Auto Hinter to automatically add hinting instructions to the imported font. Subpixel positioning. Subpixel positioning can be adjusted. This is a free type feature that allows glyphs to be rendered more closely to their intended form. The default setting of auto automatically enables subpixel positioning at small sizes, but disables it at large font sizes to improve rasterization performance. You can force subpixel positioning mode to be disabled one half of a pixel or 1/4 of a pixel. One quarter of a pixel provides the best quality at the cost of longer rasterization times. Changing anti-aliasing, hinting, and subpixel positioning has the most visible effect at smaller font sizes. Warning, fonts that have a pixel art appearance should have their subpixel positioning mode set to disabled. Otherwise, the font may appear to have uneven pixel sizes. This step is not required for bitmap fonts, as subpixel positioning is only relevant for dynamic fonts, which are usually made of vector elements. Mipmaps. By default, fonts do not have mipmaps generated. To reduce memory usage and speed up rasterization, however, this can cause downscaled fonts to become grainy. This can be especially noticeable with 3D text that doesn't have fixed size enabled. This can also occur when displaying text with a traditional rasterized non-MSDF font in a control node that has its scale lower than 1:1. After selecting a font in the file system doc, you can enable the bitmaps in the import doc to improve downscaled font rendering appearance. Bitmaps can be enabled on MSDF fonts as well. This can improve rendering quality a little at smaller than default sizes, but MSDF fonts are already resistant to graininess out of the box. MSDF font rendering. Multi-channel signed distance field MSDF font rendering allows rendering fonts at any size without having to re-rasterize them when their size changes. MSDF font rendering has two upsides over traditional rasterization, which Godot uses by default. The font will always look crisp, even at huge sizes. There is less stuttering when rendering characters at large font sizes for the first time, as there is no rasterization performed. The downsides of MSDF font rendering are higher baseline cost for font rendering. This is usually not noticeable on desktop platforms, but it can have an impact on low-end mobile devices. Fonts at small sizes will not look as clear as rasterized fonts due to the lack of hinting. Rendering new glyphs for the first time at small font sizes may be more expensive compared to traditional rasterized fonts. Font pre-rendering can be used to alleviate this. LCD subpixel optimization cannot be enabled for MSDF fonts. Fonts with self-intersecting outlines will not render correctly in MSDF mode. If you notice rendering issues on fonts downloaded from websites such as Google Fonts, try downloading the font from the font author's official website instead. Font rendering example. comparison of font rasterization methods from top to bottom. Rasterize without oversampling, rasterize with oversampling, MSDF. There's like barely a difference between font rendered, between these two examples. This one looks ever so slightly more gray than this one. To enable MSDF rendering for a given font, select it in the file system dock. Go to the import dock enabled multi-channel sign distance field, then click reimport. Using emoji, Godot has limited support for emoji fonts. CBDT, CBLC, embedded PNGs, and SVG emoji fonts are supported. Color, COLR, CPAL emoji fonts, custom vector format are not supported. EMJC, bitmap image compression used by iOS system emoji font is not supported. This means that to support emoji on iOS, you must use a custom font that uses SVG or PNG bitmap compression instead. For Godot to be able to display emoji, the font used or one of its fallbacks needs to include them. Otherwise, emoji won't be displayed and placeholder tofu characters will appear instead. Font rendering example. Default appearance when trying to use emoji in a label. After adding a font to display emoji such as Nodo color emoji, you can get the expected result. Correct appearance after adding an emoji font to the label. I don't really need to worry about emojis now, do I? Using icon fonts, tools like Fontello can be used to generate font files containing vectors imported from SVG files. This can be used to render custom vector elements as part of your text or to create extruded 3D icons with 3D text and text mesh. Note, Fontello currently does not support creating multicolored fonts, which Godot can render. As of November 2022, support for multicolored fonts in icon font generation tools remain scarce. Depending on your use cases, this may lead to better results compared to using the image tag in rich text label. Unlike bitmap images, including SVGs, which are rasterized on import by Godot, true vector data can be resized to any size without losing quality. After downloading the generated font file, load it in your Godot project, then specify it as a custom font for a label, rich text label, or label 3D node. Switch over to the Fontello web interface, then copy the character by selecting it, then pressing Ctrl-C, paste the character in the text property of your label node. The character will appear as a placeholder glyph in the inspector, but it should appear correctly in the 2D or 3D viewport. To use an icon font alongside a traditional font in the same control, you can specify the icon font as a fallback. This works because icon fonts use the Unicode private use area, which is reserved for use by custom fonts and doesn't contain standard glyphs and design. Note, several modern icon fonts such as Font Awesome 6 have a desktop variant that uses ligatures to specify icons. This allows you to specify icons by entering their name directly in the text property of any node that can display fonts. Once the icon's name is fully entered as text, such as house, it will be replaced by the icon. While easier to use, this approach cannot be used with the font fallbacks, as the main font's characters will take priority over the fallback font's ligatures. Font fallbacks. Godot supports defining one or more fallbacks when the main font lacks a glyph to be displayed. There are two main use cases for defining font fallbacks. Use a font that only supports Latin character sets, but use another font to be able to display text using another character set such as Cyrillic. Use a font to render text and another font to render emoji or icons. Open the Advanced Import Settings dialog by double-clicking the font file. I don't need to worry about font fallbacks. Variable fonts. Godot has full support for variable fonts, which allow you to use a single font file to represent various font weights and styles. Regular, bold, italic. This must be supported by the font you're using. To use a variable font, create a font variation resource in the location where you intend to use the font, then load a font file with the font variation resource. Scroll down to the font variation section, then click the variation coordinates text to expand the list of axes that can be adjusted. The set of axes you can adjust depends on the font loaded. Some variable fonts only support one axis of adjustment, typically weight or slant, while others may support multiple axes of adjustment. For example, here's the Inter V font with a height of 900 and a slant of -10. While variable font axes axis names and scales aren't standardized, some common conventions are usually followed by font designers. The weight axis is standardized in OpenType to work as follows: thin hairline, extra light, ultralight, light, regular, normal, medium, semi-bold, demi-bold, bold, extra bold, black, extra black. You can save the font variation to .trez resource file to reuse it in other places. Faux bold and italic. When writing text in bold or italic, using font variation specifically designed for this looks better. Spacing between glyphs will be more consistent when using a bold font, and certain glyph shapes may change entirely in italic variants. Compare A and A. However, real bold and italic fonts require shipping more font files, which increases distribution size. A single variable font file can also be used, but this file will be larger than a single non-variable font. While file size is usually not an issue for desktop projects, it can be a concern for mobile or web projects that strive to keep distribution size as low as possible. To allow bold and italic fonts to be displayed without having to ship additional fonts, or use a variable font that is larger in size, Godot supports faux bold and italic. Faux bold italic top, real bold italic bottom. Normal font used, open sans semi-bold. Faux bold and italic is automatically used in rich text labels bold and italic tags if no custom fonts are provided for bold and or italic. To use faux bold, create a font variation resource in the property where a font resource is expected. Set variation embolden to a positive value to make a font bolder, or to a negative value to make it less bold. Recommended values are between 0.5 and 1.2 depending on the font. Faux italic is created by skewing the text, which is done by modifying the per character transform. This is also provided in font variation using the variation transform property, setting the YX component of the character transform to a positive value will italicize the text. Recommended values are between 0.2 and 0.4 depending on the font. Adjusting font spacing. For stylistic purposes, or for better readability, you may want to adjust how a font is presented in Godot. Create a font variation resource in a property where a font resource is expected. There are 4 properties available in the variation extra spacing section, which accept positive and negative values. Glyph, additional spacing between every glyph. Space, additional spacing between words. Top, additional spacing above glyphs. This is used for multi-line text, but also to calculate the minimum size of controls such as label and button. Bottom, additional spacing below glyphs. This is used for multi-line text, but also to calculate the minimum size of controls such as label and button. The variation transform property can also be adjusted to stretch characters horizontally or vertically. This is specifically done by adjusting the XX horizontal scale and YY vertical scale components. Remember to adjust glyph spacing to account for any changes, as glyph transform doesn't affect how much space each glyph takes in the text. Non-uniform scaling of this kind should be used sparingly, as fonts are generally not designed to be displayed with stretching. OpenType font features. Godot supports enabling OpenType font features, which are a standardized way to define alternate characters that can be toggled without having to swap font files entirely, despite being named OpenType font features. These are also supported in TrueType, TTF, and WOFF/WOFF2 font files. Support for OpenType features highly depends on the font used. Some fonts don't support an OpenType features, while other fonts can support dozens of toggleable features. There are 2 ways to use OpenType font features. Globally on a font file. Open the Advanced Import Settings dialog by double-clicking the font file in the File System dock. You can also select the font in the File System dock, go to Import Dock, then choose Advanced at the bottom. In the dialog that appears, look for the Metadata Overrides Open Type Features section on the sidebar. On right-click the Features 0 O of N set text to expand. Click the Features text to expand the property, then click Add Feature. Open Type Feature overrides in Advanced Import Settings. In a specific font usage, font variation. To use a font feature, create font variation resource like you would do for a variable font. Then load a font file within the font variation resource. Scroll down to the Font Variations Open Type Features section. Click the feature O of N set text to expand the property. Then click Add Feature and select the desired feature in the dropdown. Specifying open type features in a font variation resource. For example, here's the Inter font without the /0 feature top, then with the /0 open type feature enabled bottom. Open type feature comparison Inter. You can disable ligatures and or kerning for a specific font by adding open type features, then unchecking them in the inspector. Oh, hey. Warning, loading system fonts is only supported on Windows, macOS, Linux, Android, and iOS. However, loading system fonts on Android is unreliable as there's no official API for doing so. Godot has to rely on parsing system configuration files, which can be modified by third-party Android vendors. This may result in non-functional system font loading. Marvel Rivals? He can't be doing that. System fonts are a different type of resource compared to imported fonts. They are never actually imported into the project, but are loaded at runtime. This has two benefits. The fonts are not included within the exported PCK file, leading to a smaller file size for the exported project. Since fonts are not included with the exported project, this avoids licensing issues that would occur if proprietary system fonts were disturbed alongside the project. Portal. The engine automatically uses system fonts as fallback fonts, which makes it possible to display CJK characters and emoji without having to load a custom font. There are some restrictions that apply though, as mentioned in the Using Emoji section. Create a system font resource in the location where you desire to use the system font. You can either specify one or more font names explicitly, such as Arial, or specify the name of a font alias that maps to a standard default font for the system. Sans serif. On Android, Roboto is used for Latin Cyrillic text, and Noto Sans is used for other languages. Glyphs such as CJK on third-party Android distributions. Font pre-rendering. When using traditional rasterized fonts, Godot caches glyphs on a per font and per pixel basis. Per font and per size basis. This reduces stuttering, but it can still occur the first time a glyph is displayed when running the project. This can be especially noticeable at higher font sizes or on mobile devices. When using MSDF fonts, they only need to be rasterized once to a special assigned distance field texture. This means caching can be done purely on a per font basis, without taking the font size into consideration. However, the initial rendering of MSDF fonts is slower compared to a traditional rasterized font at a medium size. To avoid stuttering issues related to font rendering, it is possible to pre-render certain glyphs. This can be done for all glyphs you intend to use for optimal results, or only for common glyphs that are most likely to appear during gameplay to reduce file size. Glyphs that aren't pre-rendered will be rasterized on the fly as usual. Note, in both cases, traditional and MSDF font rasterization is done on the CPU. This means that the GPU performance doesn't affect how long it takes for fonts to be rasterized. Open the Advanced Import Settings dialog by double-clicking the font file in the file system dock. You can also select the font in the file system dock, go to the Import dock, then choose Advanced at the bottom. Move to the pre-render configurations tab with the advanced import settings dialog, then add a configuration by clicking the plus symbol. After adding a configuration, make sure it is selected by clicking its name once. You can also rename the configuration by double-clicking it. There are two ways to add glyphs to be pre-rendered to a given configuration. It is possible to use both approaches in a cumulative manner. Using text from translations. For most projects, this approach is the most convenient to use, as it automatically sources text from your language translations. The downside is that it can only be used in your projects if your project supports internationalization. Otherwise, stick to the using custom text approach described below. After adding translations to the project settings, use the glyphs from the translation tab to check translations by double-clicking them. Then click Shape All Strings in the translations and add glyphs at the bottom. Enabling pre-rendering in the Advanced Import Settings dialog with the glyphs from the Translations tab. Note, the list of pre-rendered glyphs is not automatically updated when translations are updated, so you need to repeat this process if your translations have changed significantly. Using custom text. While it requires manually specifying text that will appear in the game, this is the most efficient approach for games which don't feature user text input. This approach is worth exploring for mobile games to reduce the file size of the distributed app. To use existing text as a baseline for pre-rendering, go to the glyphs from the text sub-tab of the Advanced Import Settings dialog. Enter text in the window on the right, then click Shape Text and add glyphs at the bottom of the dialog, enabling pre-rendering in the Advanced Import Settings dialog with the glyphs from the Text tab. Tip: if your project supports internationalization, you can paste the contents of your CSV and PO files into the above box quickly. Pre-render all possible characters that may be rendered during gameplay, excluding user-provided or non-translatable strings. By enabling character sets, the second method requires less configuration and fewer updates. If your game's text changes and is more suited to text-heavy games or multiplayer games with chat, on the other hand, it may cause glyphs that never show up in the game to be pre-rendered, which is less efficient in terms of file size. To use existing text as a baseline for pre-rendering, go to the glyphs from the character map sub-tab of the Advanced Import Settings dialog. Then double-click Character Sets to be enabled on the right, enabling pre-rendering in the Advanced Import Settings dialog with the glyphs from the Character map tab. To ensure full pre-rendering, the character sets you need to enable depend on which languages are supported in your game. For English, only Basic Latin needs to be enabled. Enabling Latin 1 supplement as well allows fully covering many more languages such as French, German, and Spanish. For Russian, Cyrillic needs to be enabled, and so on. Default project font properties. In the GUI themes section of the advanced project setting, you can choose how the default font should be rendered. Default font anti-aliasing controls the anti-aliasing method used for the default project font. Default font hinting controls the hinting method used for the default project font. Default font subpixel positioning controls the subpixel positioning method for the default project font. Default font multi-channel design distance field, if true, makes the default project font use MSDF font rendering instead of traditional rasterization. Default font generation mipmaps, if true, enables mipmap generation and usage of the default project font. Note, these project settings only affect the default project font, the one that is hard-coded in the engine binary. Custom font properties are governed by their respective import options instead. You can use the import default section of the project settings dialog to override default import options for custom fonts. Control node tutorials. Okay, I don't need to worry about this. So, I don't think I need to worry about class reference either. So I think we're done. I think we're finally done with this section. Finally. So, tomorrow, I'll start working on my game. That will be fun.